Okay, so I'm here in the hospital recording your lessons, but since I have no internet connection, I'm going to play this game for a little bit, and then we'll start recording your lesson. See how far I get until the internet gets on. Oh yeah, you guys are probably wondering whether I'm having a boy or a girl, or maybe you figured it out, I don't know. Oops, alright, never mind. Okay, so today, well, we're doing 4.4 and 4.5. They're actually very closely related. We can probably get through all of it within this first set of notes. I'm going to do something a little bit different for 4.5. I know it says comparing volumes of spheres, cylinders, and cones. What I'm actually going to do with that section is put items together, like multiple three-dimensional items. We're going to find the volume of compound figures, because that's basically what they're telling you to do. So we'll do that with different shapes. So filling cones and spheres, page 50, March 22nd, not the 20th, so 22nd. All right, so March 22nd, filling cones and spheres. If a sphere and a cone have the same dimensions as a cylinder, how do we find the volume? How do we compare the volumes? What formulas for the volumes and spheres and the volume of a cone can you write using these relationships? Okay, so we know how to find the volume of a cylinder, this shape here. We're going to compare a sphere, that's a ball, and a cone with the same radius and the same height. So what you'll notice is all three of these items are all the same height. That's why I put them all together here. And here they all have the same width, okay, which means they have the same diameter, which means they all have the same radius. Okay, now this is important because these are all based off of this cylinder. The cone can fit inside the cylinder, right? It fits right inside. This sphere will fit right inside from top to bottom. You'll notice it's in the middle to the middle of the top. Sides match up really well. So they're all based on something you already know. They're all based off of this cylinder. So what I'm going to do is I'm going to get this out of the way, and we're going to actually calculate these three items and see how they compare to each other. Okay, so let's start off with the equation for the volume of a cylinder, which is base times height. Okay, so this is going to be base times height, and the base, just as a reminder, this is our base. Down here, that's our base. Okay, and that's the area of the base. So I'm going to say area, wow, that's horrible handwriting. Let's undo that. Let's try again. Area of base. Area of base times height. Okay, and in this case, I'm going to come up with some numbers. We'll fill this in so it makes a little bit more sense. Start filling this. Okay, so I cleaned this up a little bit for the area of a cylinder. It's the area of the base, so I figure out the base, that's the circle on the bottom, times the height. And here's the equation for area of a base. So I did this in yellow and in green, so I highlighted in the two colors. So area of the base is pi times r squared. The pi is 3.14. The r squared, the radius is 5, so I multiplied it twice, times 5 times 5, and the height is 10. Okay, so that's the area of a cylinder. Okay. Now, before we move on to the sphere and the cone, I'm going to show a video of what the sphere and the cone look like as far as their volumes are concerned. So I'll post this video as a link as well.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. volume of the cone is a third of the volume of the cylinder.
Okay, so the volume of a cone, as we saw in the video, is 1/3 the volume of a cylinder. Remember, they poured this cylinder into this cone 3 times, so we're going to use the same exact formula. Area of the base. Okay, I'm going to do this in a few less colors. Area of the base, which is pi times radius squared. That's why the 5 shows up twice. Times the height, and the height again is 10. But now, since it is 1/3 the volume of this cone, we'll divide it by 3. So you have to know how to find the area of the base or area of the circle first. So they're all based off this idea. That's why I'm continuously putting this data on here. Again, you don't have to write this down, but if you don't know what these are, you will be lost. Okay, so volume of a cone, same as volume of a cylinder, except for you divide by 3. Okay, you divide by 3. Okay, now off to volume of a sphere. Okay, so here's a sphere. This is a different person. He does a sphere. They're the same height and the same radius as this cylinder, and he's going to fill it up with this blue water, and we'll see how many times it fills up this cylinder. So we filled that cylinder up, looks like 2/3, and he's going to use a cone to fill up the rest of the space. So what you'll notice is that this cylinder was filled up 3 times by only cones, or twice, or once by a sphere and once by a cylinder. So that means that this sphere is equal to 2 cones. Okay, so this part here, what you'll notice is I still have the same exact equation all the way through. Area of a base, there it is, and it shows up in my equation, pi times radius squared, that's why it shows up twice, and then times the height. I'll do the same color. Okay, there's the height. Okay, the height is 10, which is right there again. And then we divided by 3. We divided by 3 because that represents a cone. So this section of this equation is a cone. This first part is all a cone. Okay, this is my cone. Okay, now because it filled up 2/3 of this cylinder of the same base and height, 2/3 means I divide by 3, and then now my last section I'm going to multiply it by 2 because it represents 2 cones. Okay, a sphere in volume is equal to 2 cones. So you're going to need to know this equation for cones and this equation down here for, this is for spheres. Spheres, let's write that down. This is a sphere, and this down here is a cone. Okay, 2 cones equal 1 sphere. Okay, now if you don't know how to find the volume of a cylinder, you cannot do any of these other ones. So you have to be able to do this one first before you can do either one of these two. These are both based off of volume of a cylinder. Your homework or your classwork today will be here, if I could find it. I'll post it on the classroom. There should be copies in class as well. And we're gonna do combinations of items and half spheres as well in your homework. If you have any questions, email me, take a picture, or ask Miss Porter. She'll email me and I'll email you guys a response. Okay, so your homework will look like this. Volume of spheres and hemispheres. To find the volume of a hemisphere, half of a sphere, you do the same thing that you would do for a sphere, then you just divide it by 2. So it'd be essentially a hemisphere volume is the same equation as a cone. Here's some cones for you guys to do some practice. And lastly, compound shapes. These are just rectangles, rectangular prisms. with the rectangular prisms. Here's a cone and a rectangular prism. Here's an ice cream cone. So a cone with a ice cream scoop on top. So you should have enough data here to answer these questions. If you can only get to these first two, you're okay. This last section is a bit of a challenge. So if you can get to this, you should be all right. If you have a little trouble on this, that's okay. I'll try and make a video going through the answers of this section. Okay, so you should have 3 pages. Next class, you'll play a game for your review, which will be Friday. You're playing a game, you're playing your Kahoot game, and you'll have your study guide available. So, and then you'll test next week Tuesday. Alrighty, have fun, watch the video as much time as you need to get some examples. I'll post a link of some other videos that will be helpful in understanding the volume of these items.